So these are some of the various roles like throughout my journey, from analyst to design advisor to consultants. And these are my active certifications: 101, 201, 301A, 301B, and 302. So this certification journey we will be discussing at end of this session. Okay, so these are some of the basics like ADCs, modules, big IP devices, platforms, and some of the protocols: HTTP, SSL, and DNS. So the blueprint I had divided into 4 sections: setup, configuration, maintain, and troubleshoot. Okay. So this is the basic outline of the course. So like setup is something when we receive a new hardware. So we need to like perform some initial basic configuration, like setting up the management IP, licensing, what are the modules we need to provision, and some basic things like if we have some syslog server, SNMP, and DNS and HA, which is basically for the failover purpose. Then under the configuration, it's actually where the magic is going to begin, where we will be configuring the components in the LTM, which are nodes, pools, virtual server, different load balancing methods, and then monitors, different types of monitors, profiles, rules, and policies with some example, and NAT, address translation, and some of the topologies. And then in the maintain section, so it basically is going to cover when your device is already in production and it is processing the traffic. So what are the things which we are required to know, like virtual server order of precedence, how they treat a new connection, what are the different kinds of like configuration files, then backup and software upgrade procedure. And then, so the 4th section, like troubleshoot kind of a section, which we would be covering throughout the course after every configuration, mainly using the tools like TCP dump and Wireshark, and using curl as well. And we will also see how we can see the logs and statistics and how we can make use of it, and how to take the tech support, which is basically we call like QK view in the F5 Vault. So these are basically the key concepts which are required to actually go into the F5 Vault. One is OSI layers, like there are 7 OSI layers, which everybody knows. So what are the protocols which are involved at each layer, and how basically their connection is set up, some information about the headers, how their traffic flow is. Like suppose if you are using a web application. So in web application, so at layer 7, we are going to use HTTP. And at layer 4, we are going to use TCP. And if it is HTTPS, then there is an involvement of SSL as well. For networking concepts, so we are required to have some basic understanding of routing, switching, and firewall, what their purpose is. Like in routing, most of the time, it's only static. So we will be only focusing on static routing. So I guess for this course, like static routing, if you are aware about the static routing, it's more than enough. Some basic concepts about layer 4 protocols, TCP and UDP, how their connection setup is, what are the flags involved, and some layer 7 protocols where HTTP, SSL, and DNS, they are the most commonly used protocols, which are like I would say these are the most commonly used applications which are hosted on F5. So we just need to have some basic understanding, and these are the three protocols I would recommend that as much as you can read about these protocols, which I guess if you are working as an F5 administrator, then eventually you have to read that. So these are the basically like key concepts which are required. So moving on to next slide. So training approach throughout the course would be like we would discuss the concepts first, then their use cases, then we will be configuring it, then we will be verifying the configuration, and what are the routine tasks which as an F5 administrator which everybody would be doing. Okay, so if like can just like I would just like to know how much experience you have in network and exposure or experience in F5, and what is your expectation from this course. If anybody want to speak up. I hope I am audible. Hello. Hello.
Yeah, sir, you are audible. Yeah.
So does like anybody would like to add something on this? Maybe anybody? So all of you are from networking field, am I correct?
Yes, I am.
Okay, so can I know how much experience you have?
Yeah, I have 7 years experience in networking, like in the ISP platform.
So is it okay if I may your name?
My name is Mosin.
Okay. So do you have any exposure to F5?
No, 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 sir.
Okay. Okay. So I'm moving on to next slide. So basically, like throughout the course, there would be a lot of like TCP dumps and Wireshark after every lab. So I would expect that it's going to be an interactive one so that I can clear more doubts. Okay, so this is something my expectation is. Okay, so I'm moving on to next slide. So Mosi, can you just explain me like if you have this setup at home network, we have like broadband connected to Wi-Fi modem, internet, and so these are like some of the applications which we use.
Yes.
Okay, so can you just like let me know like if there are other audience as well, so I would also request them to intervene as well. Okay, so like what are the things which are happening behind the scene, like suppose if we are just at home and if we open a browser, let it be on the phone or let it be on your laptop, and if we just type google.com, so what are the things happening behind the scenes? So what are the protocols which are involved?
Uh, as far as I know, when we type on the browser like google.com, first of all, it will resolve its IP address from the DNS,
Okay.
and then it need the gateway IP address to reach out to the internet. So these two things will be taken place at the first. Then the request will be forwarded to the ISP. Then ISP will take care and forward its request to the stream and so on. Then the request will come back accordingly.
Okay, yeah, so that's actually correct. Okay, so first of all, when we type google.com, so internet doesn't understand names. So we need an IP address. So for that, we would need to go to the DNS server to go and check for the IP address. So first of all, our request will go to the DNS server, then we will get the IP address, and then that IP address, so the request based on that IP address, it will be sent to the servers so that we will get the response back. So basically the protocols which are usually involved are DNS, SSL, and HTTP. In the case when we are typing google.com. So guys, just let me know if I'm writing something. So are you able to see on the screen?
Sir, currently none. But if you can write something, then we can see.
No, I'm actually writing, but somehow. Okay, so let it be. So actually, some of the slides I kept like blanks, so maybe I can skip it. So later on, I can work on it. Okay. Okay. So this is one of the simplest network. Yes. So like suppose if we have a fictional company called example.com, it can be anything. It can be an e-commerce website. It can be something related to books library. It can be anything. Okay. So as per organization, so like like we are going to have some infrastructure in the organization. We are going to have some web servers, email servers, database servers, app servers, firewalls, VPN routers. So DNS server is required. And then based on the number of users, so there would be internal users. So internal users are basically, they require access of the networking devices or maybe the servers to manage them. And then some vendor or partners, so which would be using the SSL VPN to like update a few things on some apps. And then there would be some remote workers who are actually doing work from home. So basically when we do work from home, so we are going to connect to a VPN, and then after that we are going to access our network resources. And then there are users who are actually like consuming example.com. Like we are like we all are users of amazon.com or eBay or YouTube. Okay, so I have just explained you. So the basic idea of having this slide is to show you where F5 fits into this picture. Okay, so I'm just trying to give you a basic idea. So the green line in every slide is basically for the DNS resolution. Okay, so as we just discussed that if we are using example.com, so the request is going to the DNS server. So the company is also owning the DNS server. So the request will go to DNS server first. Then then they will take the IP address, and then so they will enter through the internet to the company network through the core routers. And usually there is a firewall in front of the servers to filter out the traffic. And then we have web application firewall, which is basically going to inspect all the traffic for any suspicious activity or any attacks. And the website is hosted on the web server. Okay, so that's how they are going to access the website. Now, vendors and remote DC workers, like suppose they are using the URL vpn.example.com to connect to the VPN. It's an SSL VPN. So they are just going to open their browser and type vpn.example.com. So let it be the user from remote network or vendors like segment, it's going to go to the DNS server first to resolve the IP. And then again, it's going to go through the so in this case, basically users are connecting to VPN first. I forgot to add that line to the VPN. So once they are connected to the VPN, and then they will be accessing all their internal resources. Then internal users are again accessing the same DNS to get the IP, but it's all happening internal, so the traffic is not going internally. So that they can access the web server. So guys, please let me know if I'm going fast or if you have any questions in mind. So you can just ask me anytime. Even if you want me to slow down my pace, so you can let me know. So these are basically some of the slides I prepared to actually like draw a few things to to let you know the DNS. So basically DNS flow, so it's basically the DNS hierarchy. So there is local DNS, which is provided by our ISP. So then there are three components of DNS: root DNS server, TLD, which is basically top level domain, and ADNS, like authoritative DNS. So in the last slide, when I showed you this DNS, so this DNS is basically ADNS, which is managed by example.com or any organization. Okay. So the user DNS request will go to LDNS, and then LDNS will go to root. Then root will give them the IP address of top level domain DNS. Then top level domain DNS will return the address of the ADNS to LDNS. And then LDNS will send the request to ADNS, and then ADNS will get the reply, the IP address, and then it will be forwarded to the user. So can somebody explain me like how the connection is established and like terminated in TCP?
Yeah,
Okay, so
there
this
is a three-way handshake in the TCP. So it's the sync, ACK, and ACK.
Okay, and how it is terminated?
What do you mean by terminated? Like
when you don't need a TCP connection.
When
like
we don't
suppose, so like suppose you have opened up a SSH session to any router or firewall.
Okay.
And when you when you close it or when you type quit, so what happens? Like it's going to terminate the connection with the server, or maybe it's a networking device, so it's going to terminate that connection.
So I believe you meant to say that the session, about the session, right?
Yeah, like there are two things in TCP. One is actually like how the connection is established, which you just told me that since SYNAC and ACK. So after that state, so once both have received SYNAC and ACK, client and server, so then they can like do the data transfer. And when they don't need it, so the connection is terminated. So there has to be a mechanism so that like both client and server, they know that, okay, this connection is not required. Or else if that connection stays in the system, it's going to take the space. It's going to take some memory in the system. So there has to be a mechanism to terminate the connection. Like, would you mind that, like, suppose you must have seen that many a times, like we open something, any CLI or like GUI access to any device, let it be a firewall or a router, and we just click close, like click the cross, and we just go it. Okay, so but that's so like session is still there.
Yes.
Yes, so that connection is still there. So we need like some mechanism to close that connection. Like suppose if we just access it like maybe like 10 times a day. So after 6 months, like if, so like 10 users, like 10 administrators in the team. So if we are not closing the connections and everybody is just clicking on the cross and going away, so how many connections will be there on the server and the router, which eventually is going to impact the performance? Am I making sense?
Yes, yes.
Okay, so there is always two things in the TCP. One is connection establishment, and one is connection like termination. And there are some TCP timers involved, which actually check at each level, at each point. Like suppose if I am not receiving any traffic, if like from the client side, so my device after 5 minutes will say, okay, it's been idle for 5 minutes, so I'm terminating the connection. So those timers are also very important. So this is basically how it is. Like A and B, it can be two servers, it can be a client and a server, it can be like an administrator or a firewall or a router or a switch on which we have logged in. So the first section in SYNAC ACK is the basic like connection established. So for every device, for every TCP connection, it has to go through SYNAC and ACK. And after that, when we say A, B, C, D, E, F, G, and FUBA, it's basically the data where both are in the established state, and whatever we send, we will get an acknowledgement for it. When we say like data is ABC, so we are going to get the acknowledgement for it. Okay. In the last part, so like connection established is we call it a three-way handshake because like three packets are involved: SYNAC, and ACK. for connection termination, it's a four-way handshake kind of a thing, where if A wants to close the connection, so A will say fin. Like suppose A logged into the router B and he just crossed it, and after the idle timeout expired, say is 300 seconds, which is 5 minutes. So after 5 minutes, it's going to send a fin. Fin means that I don't need this connection. I want to terminate this connection. So router B is going to acknowledge that fin saying ACK, and then it's going to send its own fin. And then A is going to send the ACK. So this is the connection termination phase, how it's done. Okay, so on the extreme left and right side, you can see the states. These are the TCP states. Like established is when you can send data, and then it goes through some states, transition states, like time wait and closed. At the closed stage, both of them has removed the connection from their connection table. So because of that, space is free now. Any doubt in this?
No, sir, all good.
Okay. So HTTP, I also wanted to explain. Okay. So like anybody like, okay, so for HTTP, so what is the protocol involved at layer 4 in HTTP? Is it TCP or UDP?
Sir, it's for UDP.
No, HTTP actually uses TCP. Like some of the protocols like FTP, HTTP, HTTPS. So they use like TCP. And if you talk about the protocols like syslog, SNMP, DNS, they use UDP. Okay, like suppose if you're accessing google.com, so when we type http google.com, it automatically takes http as google.com. So that is layer 7 protocol. Okay, after that SSL, but before that, we have to make a TCP connection with the Google server, which we just saw, like SYNAC and ACK. After that, it's going to be a HTTP request. Okay, so okay, let me try to. Okay, so can you see Vaishak?
No, sir.
Hello. I'm representing Vaishak on the screen now.
No, sir. It's not visible.
No, we can see only the Zoom screen, like Zoom window there.
Okay, now I got it. What is the problem? Okay, if I do this. Okay. So now can you see if I'm writing anything?
No, we can see only HTTP over there. I believe it's a slide. It's a part of the slide.
Mm-hmm. Okay. So can you see Vaishak now?
Yes, we can see now.
Okay. So this is just to give you an idea. Okay. So like suppose if I accessed f5.com from my browser. Okay. So I have captured all the packet. So the first thing it's going to be DNS. Okay. So I'm filtering out with the DNS. So we can see that it's UDP. So F5 is going to show you layer wise. So this is layer 4, where it is using UDP. Okay, so and after that it is DNS, which is layer 7, and I can see the protocol is DNS. It's a query for www.f5.com. Okay, so and now we got a response somewhere, something like this. So we can see the answers. So we got one of the IP 65.8.11.72. So my machine sent a DNS request, which uses UDP at layer 4. It first asks the query. We can see that like it's a query response, and at the same time for the query, we will see right query and query response. So we are getting this IP like 65.8.11.72. Now, when I try to use HTTP, so can I see some of the, okay, so there would be no, okay. So when I see, okay, so this is F5. And when I go and follow the TCP stream, in that I can see, like, first of all, there is a 3-way handshake happened between my machine and the F5. So can we see that SYN, SYNAC, ACK? Are you guys able to see?
Yes, sir.
Yes, sir, we can see.
Okay. And then after that, from this part to this part, it is SSL handshake, which is going to encrypt the data. And when we see the actual data, we can see application data. It's the actual data which it is sending. And when I check this, and we can see that all the data is encrypted. If we are not using SSL, so I can see all the data. I can see your usernames. I can see your passwords. I can see whatever you are doing. So I can see everything. So SSL is one of the key thing for which F5 is being widely used. So SSL is something which is going to encrypt our data. And so in this case, okay, so we can cover it later as well. Okay, so guys, can you see? So let's see the presentation again.
Yes, sir.
Right.
Okay. So in this topology, where F5 fits? Where F5 fits? So like we have different modules in F5. Like we have LTM, we have GTM, we have APM, ASM, AFM. These are like some of the most commonly used modules. There are some other modules as well. Okay, so have we heard about these modules? LTM, GTM, APM, ASM, AFM, just the name?
Yes, sir. Just heard about.
Okay, so like it's basically one device in which we have these software modules. We don't need to buy any card or any other hardware. It's inbuilt into the operating system of the F5 device. And these are license based. So we can just purchase the license and activate the license. And depending upon our requirement, so we can use the module. So LTM is something which we are going to use in front of the servers, in between the servers and the firewall. Okay, so what LTM is going to do is basically, so in our previous example, when we saw that like there was some IP address for F565.8.11. It's like 72 something. So what's your understanding that where is that IP is configured? Where that IP is configured? Is it directly on the server? Just any thought? Okay, so that IP address is basically configured on the LTM as a virtual IP or virtual server. And in that virtual server, we are going to create a pool, and that pool is going to contain the backend servers, which are going to receive the traffic. So our F5 is just receiving the request, and it is selecting the server and forwarding the request to the server. Is that clear? Okay, so LTM is something which we are going to use in between firewall and the servers. AFM is their network firewall solution. You can just consider it as like we are applying access list on the AFM on the basis of source and destination and ports. ASM is their web application firewall solution, where any traffic, which is like suppose if there is any traffic for f5.com, so it's going to go to ASM, and ASM is going to detect and take action on the basis of layer 7 attacks. Okay, so ASM is basically their web application firewall. So web application firewall is only for web traffic, which is HTTP and HTTPS. So ASM is a layer 7 firewall, whereas AFM is a network firewall on which you can take like permit or deny the traffic on the basis of layer 3 and layer 4 information, which is IP address and port. So, and another thing, APM is their VPN solution. So instead of creating the SSL VPN on a router or on a firewall, you can just license another module, APM, activate it, and then you can create a VPN on that firewall. And it can do a lot more things just other than VPN. ASM, APM are one of their most demanding modules in the industry. LTM as well. And we can just license another module and we can use it as a DNS server. So in one device, F5, you can have 4 different modules, 5 different modules according to your requirements. And it can act like a DNS, it can act like a VPN device, it can act like a web application firewall, it can act like a network firewall, and at the same time, LTM is their most basic device, which is actually going to receive the request and distribute the traffic among the servers. If anybody has any doubt, so if they want to ask anything, can ask.
One quick question here. You said the license can be activated, right? So,
yes,
like, is anything need to be changed on the hardware as well? Like, especially like adding these modules would take up a lot of CPU power, right? So
Yes.
I think anything needs to be upgraded on that front. Say if you are using just LTM, that's okay. But if you are adding any other modules here, we need to upgrade anything on the memory side as well.
Yeah, like see, it basically depends on the hardware you are using. If your hardware is like sufficient enough to give the resources to the module. Okay, so every module is going to take 3 resources: CPU, memory, which is basically RAM, and your disk, okay, which is basically your storage. Like suppose if you already have LTM and GTM, and if you want to license APM or ASM, so it will not allow you to provision it unless and until you have the required resources available. If you don't have it, then we need to reach out to the F5 support, and then we need to check if we can upgrade the resources. Maybe we can upgrade the CPU, maybe we can upgrade the memory or storage. So accordingly, it can be done. But yeah, this is something which has to be taken into account if we are doing it in some existing production, like existing device which is already serving the traffic. Okay, so like when you are going to do it, so later on we are going to see. So when we actually provision the modules, okay, so it automatically takes the resources. It won't allow you to do it unless and until you have those. So you have those so like resources available. So it
Got
might be the case. It might be the case that you might need to upgrade anything. Yeah, and it might not be the case if you already have a very high-end device. Okay, so under which you can like module, so that you can sort of provision all the modules. So it basically depends on the hardware what you have.
Got it. Understood. And one more quick question on top of it, the earlier one. Like, are the modules available on a virtual FI instance as well?
Yes, yes. All the modules are available on the virtual instances as well. The only difference is that virtual server is not hardware specific. It's basically throughput specific. So you might need to upgrade your hypervisor.
Got it.
Yeah. So all the features, let it be hardware or virtual edition, you can use all the modules. The only thing is that modules are license based. So their most basic module is LTM, which comes with every device. You don't have to take the license. Maybe there are some features of the LTM like iRule LX. Okay, you want to use it. So you might need to have some additional modules. But yeah, LTM is their most basic module. And after that, based on the license you have and what like modules are already licensed for you, if it is unlicensed, so then we need to purchase it and we need to provision it.
Okay, thank you. That makes sense.
Okay. So yeah, so like this is the basic like module placement kind of a thing, where we are going to use like LTM is just in front of the server, and ASM is their web application firewall, AFM network firewall, APM VPN solution, and GTM is their DNS solution. Okay, so basically,
sir, I have a quick question here. So
yes.
it seems like we purchase a blade for like in a checkpoint. So it's the same like we need to purchase a module like in this.
No. So okay. Modules are software based.
Software based. Okay.
It comes with all the operating systems.
Okay.
The only thing you need to buy is the license. Okay. So as you say, blade basis, so which I have covered in this session as well in one of the slides. Okay. So I will be showing you that as well. Okay. So there are actually different variants of F5 available: virtual, hardware, a virtual appliance and one of their very good high-end devices like Viprion, which is basically chassis based. So actually you can remove and add the blades.
Okay.
Okay. So now LTM. So it's now few slides are basically LTM based. So guys, can you just give me 1 minute? I think someone is at door. So is it okay if I can just put it on mute?
Yeah, sure.
Okay. So before that, I'll just show you this slide. So maybe you can just. Yeah, guys. Back. So guys, am I audible?
Yes, you're audible.
Okay. So like assume a situation when there is only one server. Okay. So there is a user is accessing some website, maybe example.com. So there is only one server. So if that server goes down, so you don't have any redundancy. So business down. And second case, if you need to upgrade the software version of the server for the security purpose, so the server is going to reboot many times. So again, it's going to impact the business. And then there are some of the tasks which actually takes a lot of load on the server. So one of the tasks is SSL. SSL is because SSL is doing all the encryption and decryption part. It's very resource consuming on the server. So there are case studies that if there is a server, if you just install 3 or 4 servers, so it's gone. Okay. So SSL is going to actually is going to degrade the performance if we do it on the server. Then compression is one thing. So what is compression? Like suppose if you access Amazon.com over the internet, so there are a lot of pictures, a lot of data which comes. So every picture, every image is gonna have some size. Okay, so all the data to save the bandwidth to make it more faster. So server is going to use some compression technology to reduce the size and to send it. It again takes a lot of effort on the server. So it's again like resource consuming. And then like suppose if this website is available, it's been accessed throughout the world. So all the just assume google.com, how many people are using. If it's just one server, how many connections a server must be receiving? Is that server going to handle all the connections by itself? Once all the connections are done, memory are full. So it's again either going to be a performance degradation. Like when we hear those issues, like web page is taking, it's a slowness issue, it's latency. Yeah, so most of the time as a network engineer, we spend time on checking our ports and firewalls, but most of the time, like I would say 70 to 90% of the time, it's a resource issue on the server. It can be on layer 4 or it can be on layer 7 on the server. So these are the few things which are drawbacks. So basically LTM, now we can have in this image, like between internet and the server, we can have LTM module. Okay, so LTM module. So basically, now we can have multiple servers. Okay, so that IP address, like when you resolve google.com, like suppose it resolves to 1.1.1.1, that IP address, we are going to configure it on LTM as a virtual server. Suppose we configure a virtual server 1.1.1.1, and we are going to assign a pool. In that pool, we are going to add the 3 servers. And we are going to define a load balancing mechanism. Like suppose if we select round robin, so it's going to distribute the request one by one to each server. So the resource, so the connection distribution is equal among all the servers. And there are various load balancing algorithms available, which can actually like forward the request on the basis of how server is performing. What's their CPU, what's their memory, how much connections they have, all these things they can take into the picture. So LTM, I would say it's like intelligent device. So we have like several load balancing mechanisms involved. So anybody has any doubt in this topology? Like what LTM is doing basically? Okay. So these are some benefits of LTM. Somebody just messaged on chat. I'm not able to open.
No, sir. Actually, this was for me. So no doubt.
Okay.
Thanks.
Okay. Okay. So like, so multiple servers we can have in case if one server is down. So we have 2 servers. So who can serve the traffic? Okay. Now we have different load balancing methods involved, which suits our needs. So we can just select that. Like suppose out of these 3 servers, if like suppose if one of the server is down or is having issues, so our LTM will not forward the traffic to the server who is having issues. It will only forward the traffic to the servers which are up and healthy. So which basically we apply monitors to the virtual server, which are going to check the availability and performance of the servers. If one of the server goes down, so it will detect it, it won't send the traffic to the server. So it's for failure detection. Like suppose based on the load, like suppose if it's e-commerce website and if it's Diwali or maybe Christmas, and if we have some Flipkart big sales and everything. So it's easy to add the servers. We just build the servers and we just add the servers in the pool, and it will be ready to receive the traffic. So we can add or remove the servers as per our needs. So scalability. Again, if server needs to be patched for security purposes, so we can just disable it on the LTM, then they can do the patching, and then so they can bring it up, we will enable it, and they can, so the same way they can proceed with the other 2 servers, so there will not be any business down. So the traffic will only be sent to the servers which are up. Okay. So instead of using SSL certificates on the servers, so LTM can take this task. You can offload this task from the servers to the LTM. And LTM, I have seen it's capable of handling 200, 400, 500 SSL connections, SSL certificates at the same time. So it's like so SSL offloading is one of the purpose. Even if you just have one server in the pool and you don't need any load balancing, but still LTM is used for SSL offloading. And then there are some of the things like caching, compression, persistence, high availability. We can have two LTMs, one active, one standby. So traffic control. And like traffic control is one of the thing which is basically used done by iRules, which is basically a scripting tool, TCL based scripting tool. So you can control layer 4 to layer 7 traffic with iRule. Like suppose if your request comes to example.com and if all the 3 servers are down, so then I can take a decision that, okay, send me to the maintenance page. Like that sometimes we see that, okay, we sorry, we are under the maintenance, so we will be available shortly. So LTM can do all these things. You can control the traffic from L4 to L7. Then template based configuration, which is basically their IAPS. So instead of going to different places and configuring all the components, so you can have a template based configuration like wizard based. So where you can just do next, and it will ask for you some information, and you just need to supply the IP addresses and all those things. It will automatically create your configuration. Automation, it supports almost all the scripting languages. Let it be Python, let it be Java, let it be C, let it be Perl, Python, Shell. It supports all the programming languages. So you can actually automate the things according to you. And the good thing about F5 is there are so many their packages available that you can just download it. For that, I would say that you need to have like some of the basic automation like understanding. It supports Ansible, it supports Ansible Tower, it supports like Terraform. Okay. And it has inbuilt DOS, DDoS protection. It supports all the newer protocols, let it be HTTP version 3, let it be Quick. It supports almost all the new protocols. And when I say it is protocol aware, so in that we use profiles. We apply profiles to the virtual server, which are basically layer based. So if we apply HTTP profile, so LTM will know that, okay, LTM is going to receive HTTP traffic and it will handle the HTTP traffic intelligently. And we can change some of the parameters as well. And connection management is again dependent on the memory and the resources. But yeah, like close to 2 million, 3 million, 4 million connections I have seen on the F5 at the same time. So it's like, it can have some good like connection and like throughput count, but again it depends on the hardware what you have. Like of course your hardware F5 is going to have more connection limit than the virtual. Anybody has any doubt? Okay, so APM is their VPN solutions. Okay, so APM, actually we need to have LTM, and with LTM we can use APM. So APM is like, let me show you the example. So their policies looks like this. So these are their access policies. Okay, so this is one of the most amazing and impressive thing that F5 has created. We create the policies what you are seeing right now. Okay, it can be very simple and it can go so like very complex as well. So like in the first page, you can see that you will get a login page. User will enter username and password, and then it will send it to AD server for authentication. If it is successful, you are allowed. If it is denied, then you will fail. And in the next, you can see that it's going to do some pre-checks. It can do some endpoint security check, like when you get a login screen. So it can check for what operating system you are using, what version of the operating system you are using, if you have antivirus installed, if your antivirus is updated, if you are accessing it from your personal device or company device, if you are accessing over internet or company network. It can do all kinds of security check, endpoint security check. And then based on that, you can take decisions. Like if it's Windows, it's allowed. If it's Linux, it's denied. If it is Mac OS, it's denied. If it's like iOS, like iPhone, like allowed. So you can take like decisions as per your requirement. So APM, I would say the way they have, so actually this is called VPE, virtual policy. It's called Visual Policy Editor. It's which makes APM one of their best selling device in the market. So when it comes to SSL VPN solution, at the same time, you can have multi-factor authentication as well. You can have token based, you can have OTP based like authentications. Okay, and it saves all your passwords and username securely. And it supports like single sign-on, SAML. So SAML is basically one of the protocols used for single sign-on. Okay, so I mistyped as APE. It is basically VPE. So the figures, what you are saying, Visual Policy Editor. Any doubts in that? Any questions you guys have? Okay. ASM, I told you that it's a web application firewall solution. So you're gonna have a LTM module. So any traffic which we are going to receive on the virtual server, if we have a ASM policy on it, so it's going to send the traffic for ASM policy. It checks for any suspicious activity, and then it's going to allow or deny the traffic. So ASM, AFM, actually these are two separate modules, but if you just enable the security module, so both these are available to you, ASM and AFM. AFM is layer 4 firewall, ASM is layer 7 solutions, and it is updated, and it is also their best selling product, ASM. So it can prevent almost all the layer 7 attacks. Let it be cross-site scripting, session hijacking, cookie manipulation, XML bombs, DOS attacks, forceful browsing. It can actually do all kind of things. Okay, so this was ASM.
Sir, just a quick question. So why we are using then if we are not using this device? So what is the difference between the AFM and the next generation firewall? Like if we are using this, like you have confirmed that we are protecting from the layer 7 attacks.
Yeah.
So just wanted to confirm the difference between like.
So basically, ASM is only for your web application firewall. It's only for HTTP traffic.
Okay.
It's not doing for any other protocol.
Any other protocols? Okay, fine.
Yeah, ASM it's only for web traffic, HTTP and HTTPS traffic. Let it be if you have next generation firewalls in your organization, in your network, but still we have IPS, IDS. Yeah, so you can think of ASM as a IPS or IDS, but only for web traffic.
Okay.
Yeah, only for web-based traffic, not for SMTP, not for FTP, not for SSH.
Okay. Okay, sir. Got it.
Okay, so I hope it it clears you out.
Yes, yes. It's clear.
Okay. So DNS.
Quick, sorry to interrupt. Quick question here.
Yeah,
So
yeah.
the ASM, it has the WAF as well, is it? The web application firewall, is it?
ASM is the web application
Okay,
firewall.
got it.
So basically, so when we provision the modules, okay, like LTM, GTM, APM, AFM, okay.
Mhm.
So it's one module. If we provision it, so we get both these ASM and AFM.
Okay, got it.
Okay, so yeah.
And say there's no split interface, right? Like all the traffic will go through one interface, and this is a kind of like a
No,
filtering on top. Is it LTM or ASM or AFM?
no.
Mhm.
So see, their most basic module is LTM. LTM you are going to use with all the modules.
Mhm.
Let it be you are using GTM, let it be you are using APM, let it be you are using ASM or AFM. LTM, you have to use it. It's one of their most basic module. Okay, so LTM is something like, as we said, that IP address of google.com or f5.com. Okay, what we get in DNS, it's basically configured as a virtual server on F5.
Mhm.
On LTM, it's configured on LTM. Okay, so all these policies, let it be APM, let it be ASM, or let it be AFM. So all these policies which we create in this module, ultimately we are going to bind these policies to the LTM virtual server.
Okay.
Okay, like suppose if it's a ASM policy. Okay, so user is going to access the URL. It is going to hit the virtual server, and we have a ASM policy in that virtual server. So before sending the traffic to the server, it will refer to the security policy, ASM policy. Got it?
Understood.
Yeah. So it's not like that. Okay, traffic is moving out from one interface to another interface or one device to another device. It's all modules are software based. So it is doing all the things internally. Like, is it clear?
Yes, it is.
Okay. So for DNS part, this is again like in most of the organizations we use DNS as a AD server or some Linux server. Okay. Like suppose if we have two DNS servers, so the only load balancing method which is available is round robin. Okay, and at the same time, it's more vulnerable to attacks. DNS is the second most vulnerable protocol, and it's the most attacked protocol. Number one is HTTP. Like suppose for any organization, if DNS is down, let it be there. So like servers are up, but what they are going to do as long as their DNS is not resolving, so it's not giving an IP address to the browser. Yeah. So F5 GTM, I would say it's 10,000 times faster than ADDNS or like the so your normal conventional DNS what we use. So okay, so how the basic setup is. So guys, I just wanted to ask you, are you able to see that Zoom window on like on the presentation, or it's clear? Like
It's clear, sir.
okay. Okay, so if you see the diagram now, okay, so we have two data centers. So those blue and gray areas, what you can see. suppose these are two data centers. One is in New York and one is in Singapore. Okay, so based on that, so we're gonna have two LTMs there. Okay, so you can see, so the configuration on LTM, like virtual server, it's an IP address, then a pool with 3 servers and load balancing method round robin. So can you see?
Yes.
If you have any doubt in understanding that virtual server 1 and virtual server 2 configuration, just ask me. So two websites, like one website, example.com. Okay. One is hosted in, like suppose if we use google.com, we always get google.co.in. Yeah. So the traffic is always directed to the server which is closest to us. It's not going to Google. Like US or Google.France FR. Yeah, so all those Google.com, which is in India and which is in Singapore or which is in Europe, so they all have different IP addresses. Okay, so example.com for Singapore, it will resolve to 1.1.1.1, and for US, it will resolve to 2.2.2.2. So I have 3 servers, 10, 11, 11, 1, 2, 3, and 10, 10, 10, 1, 2, 3. So any request which is received, like suppose on Singapore 1.1.1.1, it's going to load balance one by one request to the servers. Okay. Now we have 2 GTMs, one at each data center. Okay. So these are actually connected over the internet, which we call a DNS synchronization group. So both these GTM, they have the same configuration. If we make changes on one GTM, the changes will automatically be replicated to the other GTM. Okay. So the configuration into the red, it looks like this. So we create something called wide IP, which is a technical term, which is a term we are going to configure. Wide IP is basically just example.com name. And these 2 GTMs, they are going to monitor these 2 LTMs. And these LTMs are already monitoring how many servers are up or how many servers are down. Okay. So we defined wide IP example.com, and these 2 virtual servers, what we created on LTM, we are going to use in the wide IP as a pool. So basically we are saying for example.com, we have 2 IP addresses, virtual server 1 and virtual server 2. So example.com will check the connectivity of these virtual server 1 and virtual server 2. So like suppose if you are accessing it from India and your DNS request, it reaches out to any of the GTM, it will check your source IP address and it will say, oh, you belongs to India, so Asia continent, so you will get Singapore IP. So it will always redirect you to 1.1.1.1. Your traffic will always be sent to 1.1.1.1. And if you are in US, you will always be sent to 2.2.2.2. That is one of the load balancing methods available in GTM, which I think all of us has noticed that when we use google.com, we are so we always go to google.co.in. Any doubt in this?
No, sir.
Okay, so like suppose, and at the same time, if like your Singapore data center is down, or your this virtual server goes down, and you only have now New York like available, in that case, even if you're coming from India, so this GTM is going to check if my virtual server 1 is up. If it is not up, okay, then I will give it to virtual server 2. Then we will be going to US Google. So these are some intelligent decisions what GTM can make. And you have a lot of flexibility. Like suppose if you are like you can create some ranges of IP addresses in GTM, such as like a group called internal IP addresses, where you have defined your RFC 1918 addresses and some public group IP addresses. So based on that, so the same GTM, if it receives the traffic, it checks, okay, this is the internal public IP address. So it will always give me so like private IP address if I am in like in the company network or over the VPN. If I am accessing the same URL from internet, so my source IP address would be public. So it is always going to give me the public IP address. So based on these things, so you can have those things set up in the GTM. So as I said that it's actually 10,000 times fast. Like several load balancing methods are available. If we are using conventional load balancing method, so there is only one load balancing method, which is round robin, which is available, and it cannot check if that server is up or not. If it cannot check if the Singapore like website is up or not. Okay. Location based resolution, I just told you that based on your location you will get like google.com. If from India, you will always go to google.co.in. DNSSEC is actually the advanced version of a DNS, as the name suggests. It basically select DNS, select security. It's basically DNS over SSL. So which we are not seeing so much.
Sir, yes. I have a quick question. Sorry, interrupt you. So, if somehow my Singapore GTM is down, and it has a capability to understand the AC specific requirement. If I am from the AC, yeah, so it will reflect me the same page, or like it will, like, if for example about the Google.com or like, so it's just passing the traffic, just load balancing, or the diverting.
See, our GTM is basically why it called like global traffic manager. If we see the name, GTM is global traffic manager and LTM is local traffic manager. LTM is distributing the traffic in the same data center.
Okay.
Yes, and GTM is distributing the traffic between the data centers.
Okay.
GTM is deciding which LTM will receive the traffic.
Okay.
Like, was that your question, or like?
No, actually, sir, I just wanted to confirm one thing. That is fine if GTM will decide that which LTM will fulfill the request, right? Depends on the area wise.
The configuration,
The configuration, right? So my concern is if my Singapore GTM is down, right? So it will it will take my request to the other like UK or US GTM, which which is active.
Yes.
So it has a capability to fulfill my requirements if I am sending the request from the Asia Pacific, like.
Yes, absolutely.
Okay.
Like suppose actually this is a very basic setup. Okay, like if we go into the network of like maybe fi.com or maybe Amazon. Okay, so they have like okay, I can actually show you. Okay, I can actually show you. Let me know if you can see the terminal.
Yes, we can, sir.
Okay, so let me increase the size. Okay, so if I do ns lookup, which is basically going to say like fi.com. Okay, I got the answer as 107.162.162.40. It is basically the IP address on one of the web. Okay, maybe it might have checked my location. Okay, and then according to my location, it has given me the answer. Okay, you will go to this IP address. But if I want to check how many DNS servers they have, so I can type. So in their sort of terminology, when you use these commands, so NS is like name server. Name server is like DNS server. Okay. So I'm checking for f5.com. What are the name servers? We can see there are four DNS servers for this. Like pdns 151.f5.com, 131.f5.com. Okay. Now I can check them and I can ask again the same thing. Save it. This this DNS. It gives me the IP address 40. Okay. So now if I check with this 131, okay. So so you can think of that these four servers as the GTM. They will be in different continents, and they are talking to each other. They are connected to each other in a DNS synchronization group. They all have the same configuration. Now, whatever I am using the DNS, based on my location, based on my IP address, all of them are giving me the same address. So all of them are working in tandem. If one goes down, then three are available. If two goes down, then two are available. If three goes down, one is available. If now if all four goes down, then I think sometime down the line we have that outage of WhatsApp. So like when WhatsApp was down for like close to 2-3 hours.
Yes.
Yeah. So F5 will be down.
Okay.
Like throughout the world.
Okay, got your point, sir.
Okay, so let it be 2, 3, 4, 5, 6 GTM. One has to be available all the time. Okay, and if one is available and let it be any part of the world you are trying to access it, it will resolve. Any other doubts?
No, it makes sense. Thanks.
Okay, so now this is like some of the load balancing methods available in GTM. Like global availability is something that your request will only go to one data center. Like if I say that Singapore with higher priority, so all the requests will go to Singapore. So the request to New York will only go if your Singapore goes down. Okay, and round robin means one by one. Ratio means like, suppose you have a low capacity data center in New York and high capacity data center in Singapore. So you can set the ratio 3:1. So your 3 requests will go to Singapore LTM and 1 request will go to New York LTM.
Okay, that was my next question. Thanks.
Yeah. So topology is something which I discussed, that based on your location, you will get if you are from Asia continent, you will get the Singapore IP address. If you are from like America continent, you will get New York data center. Okay. CPU is both these GTMs. They are logically connected to the 2 LTMs, and they are monitoring everything on these LTMs. How many servers are up? What is their CPU? What is their memory? How many connections they have? So based on that, like suppose if LTM in Singapore, it has less load, like in terms of like CPU or connections or maybe number of hops. So the traffic will be sent to like Singapore LTM. And at some point, if your Singapore, it becomes overloaded, and if your New York is less overloaded, so your traffic will be sent to New York data center. So these are some of the things, like I just try to explain in the most like basic way. So basically, 5 basic modules: LTM, local traffic manager, which actually distributes the traffic with the servers. In the servers, GTM, it distributes the traffic within data centers, and it gives you the DNS answer. Okay, APM is your VPN. ASM and AFM are your web application firewall and your network firewall solutions. So now a very quick, because I think I have consumed a lot of time. Okay, so basically all these like type of devices, like basically LTM, so it falls under the category of ADC, application delivery controller, which is basically connected between firewall and the servers. So ADC, you know, like we just like checked that, okay, it can take load from the servers, it can improve the like performance of your application. So it is basically concentrating on like application level. So it is optimizing the application. You have control over layer 4 to layer 7. You can change all the parameters, you can alter all the traffic, modify all the traffic. Okay, so that category is basically called application delivery controller, which is focusing on application delivery basically. So application is like YouTube is an application, Amazon is an application, Flipkart is an application. Okay, like Hotmail is an application, Gmail is an application. So down the line, so there are some of the vendors which are making ADCs. So the two most common are F5 and Citrix NetScaler. Other are there as well. A10, so like Barracuda, Fortinet is making as well. So Radware is making as well. Okay, so there are others as well, like Load Balancer, INC. So like Kemp is there. Okay. If we see the market trend, so like we just focus on the right side. Okay, so in 2023, it has a like overall business of USD $2.91 billion, and it's expected to have USD $4.61 billion 2028. So it's a good to know technology which is going to stay in the market. It's not for F5, it's for ADC. Okay, anything in that? Okay, so this is basically trending. So the two most commonly used are F5 and Citrix, and F5 is always recommended over Citrix. Like I have worked on both these two. Okay, like Citrix is good, like some parts are very nice in Citrix. Okay, so both are, like I would say, they are making the same modules, they are into the same application delivery thing. Okay, Citrix is also doing some remarkable things, but F5 is the most recommended one in the market. 48 out of the Fortune 50 companies are using F5, and they are using all their products: LTM, GTM, APM, ASM. In my personal opinion, I find F5 with the more simpler management. Their tools like iRules, iHealth, their documentation is good, their support is better. So these are some of the things that I actually admire F5 about it. It's not like that I don't admire Citrix as well. Like at his place, so like Citrix is also good, but F5 is the most recommended one. So the basic drawback with F5 is that it's very expensive. So Big IP platform, it comes into 3 variants: appliance, Viprion, virtual edition. Appliance are basically fixed ports, fixed resources. Viprion, you can add chases. You have a flexibility to like add or remove the blades. So depending on your requirement, virtual like edition is on hypervisor. Okay, and it is one of the most commonly used like load balancer, application load balancer in cloud platforms. Like it's You can see it being used in AWS, Google Cloud, Azure. It's like widely used. So this is the hardware range. I'm not covering all of the ranges. Okay, so this is how like appliance model looks like. It comes in varieties of like resources where you can opt based on your requirement. Basically, it's like CPU, number of ports, memory, and the throughput. So this is how your Viprion chassis looks like. It has the most like throughput, and it has the capacity to have the maximum number of connections. So all these vertical slots and horizontal slots are the blades. So you can insert in and add or remove the blades. So basically, you get more number of ports, more CPU resources, and disk. So this is my last slide. So if anybody is interested to go for the certifications, I would say that their certifications are actually like pretty nice. They test to your like basic levels. 101 is all about your networking concepts. 201, 301, A and B, it's for LTM. 302 is for GTM. 303 is for ASM. 4 is for APM. And once you pass 101, then you can give 201. Once you pass 201, then you can give the exam in series 3 in any order. The only thing is that like 301 has 2 papers, A and B. So you have to pass A, then you have to give B. When you pass both, you will get 1 certification. For 401, LTM, ASM and APM is prerequisite. And for 402, LTM and DNS is the prerequisite. So if you guys have any doubts, please let me know.
As part of this course, I think the scope is LTM and GTM, right?
As of now, as part of this course, we would be covering LTM, but yeah, we are in the process for like GTM as well.
Okay. In the long run, we it would be ASM or AFM covered like in any of the future courses? Might be, right?
Might be.
Got it. The reason I'm asking is especially like right now I'm moving into an engagement wherein we are using AFM and WAF as well. So need some help on that, but I think I just wanted to confirm that. So LTM is good.
See, the basic part is LTM because with every module you are going to use LTM. Okay, so like it's good to have all this knowledge, but yeah, down the line, like if we can have ASM, APM, AFM, so we'll have it. And I think Arjun or maybe like Gaurav, they might answer about it because I think I'm not the right candidate for it.
So, but to summarize here, like especially this course material would cover 101, 201, and 301. Is that understanding right? I mean, the materials and
See,
like,
it
concepts.
See, it is going to cover. Like we are going to use like Wireshark, and we are going to use a lot of TCP dumps, and we are going to use. So we are going to like understand the concepts as well. Okay. Okay, so from the exam perspective, if you're asking from the exam perspective, so I can tell you that I will be able to get you to the direction where you will able to understand, but to get to know each and every option. Okay, so you might need to do it by yourself as well. But yeah, if you have those doubts, if I am available, then you can ask me during the course.
Sure. Thank you. Sounds good. Thank you.
Anything else? So I hope you enjoyed the session. Okay, so if there are actually, I was expecting it to be more interactive. Okay, so if like for the future like sessions, I would request that if we can make it more interactive.
And guys, this is LTM and GTM batch. So initially we are going to start with the LTM, and within a 3-4 days, we are going to start. It's a big days batch basically. It's Monday to Friday, 8 p.m. to whatever the time, depends on the topic. But once we'll finish with the LTM, we'll start with the GTM also. Yeah, thanks, Rohan. So thanks for the session.
Yeah.
Okay,
Thank you so
thank
much.
you. Have a good day, guys. Bye bye.
Thank you.
See you.
Thank you.
Same to you, sir. Thanks.
Yeah.